Welcome to Microsoft Build 2017. My name is Michael Ries. I'm a Principal Program Manager on the Microsoft Big Data team. And I'm here today to talk about U SQL and Azure Data Lake Analytics. In particular, I would like to show you how you can use not just C# and .NET code inside your U SQL script, but how you can actually deploy other runtimes to run other code, such as Python or even Java code, inside your U SQL scripts. So let's get started. U SQL, basically, one of the main value proposition is that it gives you a declarative framework that allows you to scale out your user code. You have three extensibility points for that. You have user-defined functions, you have user-defined operators, and you have the ability to aggregate, write user-defined aggregations. Now, what are these UDOs or user-defined operators? These are basically custom operator extensions that allow you to extend the standard relational operators with things like defining custom extractors that takes a file, creates a row set, or take a row set and output it back into a file stream. You also have user-defined processors that take one row in and do some transformations and produce one row. And you can have them either passing through, so you can write them in a way that you're only concentrating on the rows that the columns that you're really interested in, and then pass all the other columns through. Or you can do complete schema transformations as part of that. So it's similar to maybe a projection, but it has certain memory pressure benefits over a select statement. You also have user-defined appliers, or what normally you will probably call them user-defined table-valued functions, that take one row in and produce 0 to n rows. They're normally used with a cross-apply or outer apply in your U SQL statement. Finally, we have user-defined combiners that are like custom joins. And the most generic of all of them, which is a user-defined reducer that takes n rows, normally partitioned according to some partitioning scheme, and produce m rows. M is normally less than n, but it doesn't have to be. Although at that point in time, you potentially have to add a row count hint to tell the optimizer that you are producing more rows and not less. Now, these UDOs are scaled out in U SQL with explicit constructs in the language. So you have an extract statement to scale out your extractors. You have an output statement to scale out your outputters, process, combine, and reduce statements to basically scale out your processors, combiners, and reducers. So this user code is normally written in C#. But any .NET language can be used because ADLA, of course, deploys the .NET runtime to execute the C# code. And the extension libraries that we give you, that give you the model to basically tie into the row set processing, are .NET libraries. So you can use, for example, F# to write your extension code as well. But not just .NET is supported. You can actually use other runtimes, such as the C++, Python, R, JavaScript, JVM, etc. And they can be used through a user-coded C# shim. So you basically, and I will show you that with some examples later, but you basically can write a small shim for your reducer or for your extractor that then basically marshals and calls into the code and into the runtime of that other experience. Now, C++ is, of course, default deployed. So that means you normally can use, for example, the SQL Spatial library that has a native component as well as a managed component. And so you can basically then use the managed component to call out into the native code part, into the C++ or C part. You also have Python and R. We give you currently a runtime extension that you can install from the Azure Data Lake Analytics portal that we call the Cognitive Extension Library. And we'll see an example of that in a minute. You could also, for example, deploy in a similar way your own JavaScript runtime. Currently, you have to do that yourself. Or you can also make use of the JVM. We'll see an example of that later in the presentation as well. So what is happening? How do we actually process your U SQL scripts? Well, what happens is that when I take a U SQL script and compile and optimize it, then I'm basically going to get some additional resources potentially based on what I have inside my script. So, for example, if I have a reference assembly statement, I'm going to get a lookup from the U SQL metadata service to find the registered assemblies plus all the files that are registered with it, and it basically kind of collects that as well. And if I say deploy resources, I basically pick up files that are in ADLS or inside Windows Azure Blob Store, and I'm deploying that together with the script. Now, where do I deploy them? I basically deploy them into this job folder construct that contains all the code that we will then deploy into the Vertex. So as you can see here, U SQL will be compiled into C# and C++. And so you will have the managed DLLs and the native DLLs that we create as part of our compilation process, plus all the assemblies that you might have referenced. We will generate an algebra file, and we will deploy all the additional files that you have provided, both either through reference assembly or through deploy resources. And then, of course, there's a set of system files, built-in runtimes, core DLLs, and in the end, the Vertex obviously runs on an OS as well. And so that basically then all gets basically put onto one of these vertices or nodes on which you then scale out your processing. So now let's take a look with an example. In this example, I have a simple kind of Python processing that I'm using to process some tweets. Now, the tweets basically contain mentions and also topics. So what I want to do is I want to basically use some Python code to transform my row set that contains an author and the tweet into the authors with the mentions and a list of topics as well. So let's take a look at this. Here is my U SQL script that does that. The first statement here you see is the reference assembly master extension Python. So what this is a library that you can install from the portal that gives you the ability to both submit scripts, either inside the script or as a script file from ADLS, and basically do U SQL processing with it. The next statement here you see is I'm actually defining my Python script. So in here, I define my getMentions on a tweet function, and I define a function that does the getTopics, very similar to the getMentions, obviously. And then this here is the actual core piece of the Python language integration. First, I have to define a U SQL main function that takes in a data frame. Now, this data frame now this is now where I receive the row sets that I get on that vertex where this code is executing. So now that row set I can now do transformations with. So in this case, I actually drop some columns and I create some new columns, and then I return the data frame back into the U SQL context so that it's now going to be returned as the next row set of that transformation. And now here's the actual U SQL calling into that. So first I extract my tweet data. Then I call my Python reducer. Remember, we have a UDO that kind of is written in C# that now calls out into Python to execute this Python script. And we are doing that on this input row set partitioned onto the origin. So there is basically, for each one of the file names, I will get my own kind of vertex to operate on that if they're large enough. And then this is the output data frame kind of structure that I'm expecting to get out. And then I do some additional filtering here and output this to my result. So I have just submitted this about a minute ago. So what you're seeing here now is the job graph on this side here. Let me quickly expand this and then zoom in to show you the details. So you see here that I'm operating basically on these 10 files here. And each one gets extracted, and I do the processing of the Python And how does the result look like? Well, I can double click down here. And this is downloading the file and opening it. And now here you see basically the file result. So let me zoom in here. So you will notice here is the name of the person that was tweeting. Here are some of the mentions, and here are some of the tweet topics that we're operating on. So as you can see, I just basically took Python code and run it at scale, executed through U SQL. So let me go back to the presentation. Here is again the script that I went through. The Python script, the header information has to be basically U SQL main with a data frame. And we pass data frames in and out in this case. And then we basically scale it out using reducer. You can use standard libraries such as numpys and pandas. You can deploy your own libraries. You would go and basically deploy them as a zip file, and then inside your Python program you would basically instantiate them. If you want to have more information about this, you can follow this link where we have documentation that basically talks more about how to use these U SQL Python extensions. So now the interesting part of this presentation was not to show you that, but I also want to show you a little bit on how we did that. Here is the installation script that you see here that is used when you are going to install your Python extension, your cognitive services extensions. So what it does here is it basically creates an assembly called xpython that is based on some DLL called xpy.dll, which then also additionally includes these three files. It includes a PDB file, so that probably helps with error messages and so on. And it also includes two zip files, the invoke package and the deploy package. So one is for deploying basically the Python runtime, and one is for actually executing Python code. And so this is all basically Python down here. So now how do I actually implement this reducer? So let's take a look at the PyReducer here. This is the extension Python namespace where I implement the reducer. Now the iReducer interface is an interface that we basically provide you, and you basically now override the reduce method. In addition, you have the class constructor here that gives you the ability to set your parameters on the reducer. So in this case, you can provide a file name or the script directly, or you can even provide a Python version number that you might want to execute if you have more than one Python version runtime in the system. Now, how does the reducer look like? Down here, it's actually very simple, although, of course, all the complexity is now hidden in this function here, which is I'm just giving the input row set, and I'm giving this output row set plus the script file that I got up here, plus the version probably, and execute this through a U SQL Python execution.run. And then for each row that I'm getting back here, I'm basically now returning the row into my IEnumerable of iRow result. So how does this function look like? Well, let's go into the U SQL execution CS part. That's a little bit more complicated. But one of the interesting parts here is that you see here's the initialization. So you basically have, for example, the run. And this creates a script file because you have to pass the script as a file. Then you create your XDR object. You create some input and output files for the data frames. And then basically down here, you then invoke the actual Python script and then basically marshal back the results back into my output row set, which is down here. So as you can see, you're basically kind of doing a wrapper that does some marshalling of your U SQL data structures into what is appropriate for your actual runtime, and then you let it run. and invoke it from your interop layer that you're having. In this case, it is the invoke language call here. And then you basically go and execute. Now, invoke language is down here. And that, again, deals a little bit with finding the right Python version, building up the arguments, and then basically at some point in time run an asynchronous process that then does the processing. Okay, now the code is available in its downloaded form when you look at the registration. So you can go and, for example, download the assemblies, and if you want to see more details how it's being done, I think you can, know how to reverse engineer some C# code if you want to. Now let's take a look at another example. Now this example is not available right now for you to kind of download, but I will make some comments about that later. And this is showing you how I can use a Java JSON SERDI that was written for Hive and executed in U SQL. So what I do here is I have a file that contains a bunch of JSON messages, and I want to just parse them using that Java SERDI into this row set down here. So let's go and take a look at this as well. So here's my script. And again, at the beginning, at some point, I need to create an assembly that deploys my Java UDO C# wrapper function. It includes a bunch of files that are needed for my processing, including down here the JSON SERDI that I want to process. So this is something that I just downloaded from the internet, a popular JSON SERDI that is being used by people that do Hive processing. Now I'm using this JSON SERDI inside an extractor, obviously, because a SERDI is an extractor. And what it does here is basically I get my columns 1 to 5, different data types even, from some input data, which is basically that JSON document, a little bit bigger than what you saw on the previous slide. And now here is my custom extractor. Now it's called JNI wrapper.extractor. It has here an argument that allows me to say how many rows I want to pass in as a batch to my SERDI, to my Java environment. Here is the Java SERDI kind of class I want to be using, which is in that jar file. And here are some additional jar files that I basically want to make sure that are getting deployed. Now, note that this is done very explicitly. You can actually hide some of that inside your C# code if you want to make it a little bit more user-friendly. So now let's take a look at the Java extractor. So here's the namespace, JNI wrapper. And you see here is an extractor, user-defined extractor. And we can disregard the output debug string here for a minute. And down here is basically the extractor that we have to use. Here's the constructor with the different parameters. And here's the actual extractor. So what this does is it basically creates, through the JNI interface, some Java classes. And then we basically do the same thing about taking each row, mapping it into rows on that we can pass to our Java environment. And then basically do that if I have more than one value in batch mode. And then basically execute it here with the extractor process row. So this is basically all that we are doing here. Now the Java UDO code that we are invoking is doing a little bit more kind of marshalling of Hive data structures. Because one of the things, obviously, is a Hive SERDI returns us Hive data structures. So we basically have to look at this. And then we have our Java UDO, which then does make sure that the Java VM is loaded and creates all the jars, making sure that they're in the class path, etc. So this is kind of at a very high level on how you could do that. Now obviously this means that the Java runtime has to be installed on the Vertex, which it should be. So actually, let me also show you how it runs. So let's go here. I submit this local for now, so it goes a little bit faster. So you see the script run, did the extraction. I can double click on the result down here. And here is the result. So you remember this was all in JSON. Now it's in a row set format. And I used a Java jar file, 30 for that. So here's to recap what the infrastructure looks like. So obviously we have the .NET runtime inside our Vertex. So I wrote my Java udo.dll that basically contains the C# extractor that we looked at earlier. And now I want to invoke this JSON30 jar file. Now how do I do that? Well, obviously I need a JVM to be able to execute this. But I can't really call directly into the JVM. So what I have is I have a JNI wrapper.dll, which is a C# wrapper. That is the interface that I'm communicating to through the Java UDO, through my C# extractor. Now this wrapper, in turn, uses a JavaBridge.dll, which is a mixed C, C++ DLL that calls into the JNI layer directly. And obviously that needs to run inside the C++ C runtime that we have already deployed to the Vertex as well. And now that bridge now will be invoking that Microsoft Analytics jar file that you saw that I instantiated there, which is a small proxy that we wrote to basically talk to these Hive SERDES on the Java side. And then we basically, that will just invoke that JSON SERDE jar file. So I hope you've got a glimpse on how you can actually lift your own runtime and deploy it into your U SQL environment and use your most favorite language to give you an extensibility story. Now this is, however, just the start. So you might have heard us talk about improving the experience around our Python extractors and R integration, which is done similarly. We are also looking at potentially making other languages available in a more native way, so that you don't have to build all these marshalling layers yourself. If that is something that is interesting for you, please reach out and let us know. Also let us know what are kind of some of the things that you would like to achieve with that. Now to conclude, let me quickly give you an overview of some of the resources that you have to get to know more about U SQL, both with and without extensibility frameworks. We have a community page on GitHub that you can reach through usql.io, where you can find examples, custom extractors, for example, custom libraries, code, etc. You have a couple of blogs, both the Azure Data Lake blog here and my own. We have several Channel 9 videos, including I think this one at some point, that you can go and find things about U SQL. We have a lot of documentation and presentations available, including, for example, documentation about R, Python, general extensibility. The second one of the magazine links that you see there talks about basically how you can use JSON processing or use the SQL spatial library inside U SQL. And then, last but not least, obviously you can also engage with us with feature requests, with questions on either MSDN and Stack Overflow as well. Thank you very much, and if you want to reach me directly, you can tweet at me at mike.doesbigdata, or you can reach me through usql@microsoft.com as well for further questions and comments. And enjoy build.